All right, guys, in this video, we're going to do questions 14, 15, 16, and 17. However, I'm not going to do it in the order of the questions. I'm going to actually start off with question number 17 first. I apologize that the table is blurry. It's hard to copy and paste it. And then I'm going to work my way up from 17 to 16, then knocking out 15 and 14. It says here, find the probability that a randomly selected crime was committed. Well, let me actually read the bold first. The table below gives the crime statistics relating to the location of the crime and the type of crime. Robbery, murder, assault, residential, and then commercial. Find the probability that a randomly selected crime was committed in a commercial area given that it was an assault. When you see the word given and a probability question, that means conditional probability. That is an indicator for conditional probability. And conditional probability, once it's defined, the probability of the second event happening given the fact the first one already took place. So the probability that second event B, given that first event A already took place, is equal to equal to two different types of formulas, two different types of variations. And I'm going to use them interchangeably depending on the type of question that I'm solving. That is going to equal to the probability of event B and A over the probability of event A. When we're using some sort of table, that can also equal to the total of event B and A divided by the total of event A. Once again, this is to find the probability of the second event given the fact the first one already took place. So I want to find the probability that the crime was committed in a commercial area, given the fact that it was an assault. And I'm going to use the second one to set it up. So that's going to be the total of commercial. I'm going to abbreviate and assault divided by, and whatever is here goes in your denominator for its category. So the total number of assault. Now, let's focus on the numerator first. Commercial and assault. Commercial's here. Assault is there. 20 crimes are both an assault crime and it happened on commercial property. Divided by the total of assault. This right here is assault. How many crimes are assaults? That is 30, that is 20, that is 50. 20 divided by 50 is equal to 0.4. And that is how we answer the question using the conditional probability formula. You can also do it when it comes to a table by reading it and analyzing the formula. It says here, you want to find the probability that a randomly selected crime was committed in a commercial area, given that it was an assault. What is given to you in this case? Well, you are given the fact that the crime is an assault. That is given. How many crimes or assaults? There are a total of 50 crimes that are assaults. So out of the 50 crimes that happens to be an assault crime, how many of those crimes were also in a commercial area? And that is 20. That's why the probability of commercial given an assault is going to be 20 out of 50. If that makes sense to you guys. So yes, make sure you have this formula down, because I'm not going to write it down again. I mean, the formula itself, I'm just going to plug in the values into the formula. Let's move on to number 16. It says here, in the Happy Hilltop Health Home, 15% of the residents play shuffleboard, 40% of the residents play poker, and 15% of the residents garden. It's 5% of the residents play poker and gardening. Find the probability that a resident plays poker given that they also gardening. The key word is given, which means conditional probability. The probability of poker given gardening. These are percentages. Percentages are also probabilities. So the probability that they play poker and garden divided by the probability of gardening. Once again, whatever is here goes down there. Now, we're going to convert our percents into decimals as needed. How many or what percent of senior citizens, I'm going to say, does both play poker and garden? Well, that is 5%. 5% as a decimal is 0.05. Okay, how many of the residents in the bottom garden? What percentage, I mean? It says 15% of the residents garden. So 15% as a decimal is 0.15. The probability must be a fraction. So what I'm going to do is I'm going to move the decimal and my denominator over 2 units. And we did this back in chapter 7, section 1. When we're dividing with decimals and we want it as a reduced fraction, we want to have whole numbers in the numerator and denominator. So that's going to be 15. Whatever you do to the bottom, you must also do to the top. So move the decimal over 2 units to the right. That is now going to be 5. I can reduce my fraction, 5 over 15, by dividing the numerator and denominator by 5. And that gives us 1/3. And that is the answer to number 16. So let's do questions 15 and 14. It says, find the probability. Let E and F be the events with the probability of E 0.4, the probability of F 0.6, and the probability of E union F 0.8. Find the probability of E given F. Find the probability of F given E. Now remember back when we did the addition rule, I said when you see the union inside the probability formula, you can replace that with the word or. And intersection equal to the word and. Okay, so we can write this as the probability of E or F, 0.8. To find conditional probability, the conditional probability formula is the probability of B given A, which equals to the probability of B and A over the probability of A. And I can't stress this enough, so I'm going to write it right here. The probability of B and A is the same thing as saying the probability of A and B. They're the same thing. So, my events are E and F in this case. So, I'm going to replace my B and my A with E and F. So, E here, F there, E here, F there, and F down here. Also for my formulas, E here, put an F there, F here, E there. Okay. To try to keep it, consistent. So to find the probability of E given F, it equals to the probability of E and F divided by the probability of F. We do not have this. We do not have the probability of E and F, but we can definitely find the probability of E and F. We did that in a question previous in this review video series. And let's use the addition rule. Addition rule 2 to be exact. The probability of E or F, well, you can use A or B, but I'm using E or F to keep it consistent, will equal to the probability of event E plus the probability of event F minus the probability of E and F. The probability of E or F is already given to us. That is 0.8. The probability of E is 0.4. The probability of F is 0.6. And I'm just going to call this missing piece X, which is the missing part, as the variable. So 0.8 equals to 0.4 plus 0.6 is 1. 1 minus X. Subtract 1 from both sides. It's like solving an algebraic equation. I'm going to go over here. Negative 0.2 equals to negative X, which means X equals 0.2. And if you want to, work with that, if you want to know how I got that, you can just multiply both sides by negative 1. Negative 1 times negative 0.2 is positive 0.2. Negative X times negative 1 is positive X. Because X equals to 0.2, that means the probability of E and F equals to 0.2. For number 14, where I'm drawing the arrow at. To find the probability of E given F, we're going to use the format. It is the probability of E and F divided by the probability of F. So the probability of E and F is 0.2. The probability of F is going to be 0.6. I can move the decimal over to the right in my numerator and denominator one time. 2 over 6, and that equals to 1/3. For number 15, the probability of F given E. So we're just going to reverse the order of the variables. That's going to equal to the probability of F and E divided by the probability of E. Remember, whatever is here goes down there. The probability of F and E is the same thing as saying the probability of E and F. That is going to be 0.2. The probability of E is 0.4. Move the decimals 1 over to the right. 2 divided by 4 is 1/2. That's 14. That's 15. And for us to find the probability of E and F, we had to use the addition rule. All right, guys. And also, before I end this video, let me go back to question 16. The answer key has this as a decimal. Okay, when you divide 1 by 3, that is approximately 0.333, continuously. And we can make that into a percentage as 33.3%. Rather, I'm not going to do that. I'm just going to put 33%. So that's just going back to question number 16. But for number 15 and 14, that is the approach. Hope that made sense. Hope you understood it. Hope you enjoyed it. Take care.